Alright, in this video we're going to look at another counting technique. It's not going to use permutations, combinations, or factorials. It's going to use recurrence relations. So remember that recurrence relations are ones that are set up in a recursive fashion where the future values are determined in relation to previous values. And we're going to look at a example here. This is one sort of standard type of recurrence relation where you're entering money into a machine, and the machine has different ways of entering money. So let's look at some sort of made-up country where you have a vending machine where you can insert either a dollar coin, a dollar bill, a $2 bill, a $5 bill, or a $5 coin. So all of these types of currencies are accepted. Now, one of the questions we might want to ask is how many ways could you enter $3 into the machine? Okay, and we could always start by just listing a few ways out. You could certainly do a $1 coin, a $1 bill, and followed by a $1 coin. Now, we are assuming that the order that the coins and bills are entered matters, because you could imagine standing in front of the machine and putting the coins or bills in a different order. Now, maybe we don't want to count those as separately, but the math gets a lot more complicated if we don't. So another way to enter the same thing is you could put the $1 bill in first and then follow it by two other coins. And what we really need to do is think about all the ways that you could put in all $1 coins or bills into the machine. Well, if you're going to put $1 in at a time, or $1 in at a time, you're going to have to put $1 in 3 different times, and you're going to have 2 choices for the first dollar, 2 choices for the second, 2 choices for the third, and there'll be 8 ways that you could put 3 $1 currency amounts in. Right? All coins, all bills, or any combination somewhere in between. Now, if you didn't put all $1 bills or coins into the machine, then you must have put a $2 followed by a $1, or $1 followed by a $2. Right? You're really going to make 2 separate deposits into the machine. You're going to first figure out when to put the $2 bill in, and then when you have the remaining dollar, you have to figure out whether it should go in as a coin or a bill. So what we're going to do is we're going to not think about how many different $2 bills we have, but we could decide when should we put the $2 bill in first. It could either, what should we put the $2 bill in? It could go in first or it could go in second. Okay, so we have 2 ways to put the $2 bill in. At what point in time? Not 2 different ways to put a $2 bill in, but 2 different points in time we could put the $2 bill in. And then we have 2 choices for the $1 bill or coin, right? So this is the bill or coin, and this is where the $2 bill goes. Okay. Okay. That's going to give us 4 different ways. So there are 8 ways to put all ones in. There are 4 different ways to put a $2 and a $1 bill, and if you wanted to think about it, it could be 1C followed by 2, or 1B followed by 2, or it could be 2 followed by 1C, or 2 followed by 1B. Those are the 4 different ways to put 2 and 1 in. Okay, so altogether there are 12 different ways to put in $3 into the machine. Okay, so we have to sort of follow this approach if we want to put $5 into the machine, but we have more scenarios, because when you're putting $5 in, you could do it all with 1s, you could do some 2s and 1s, or you could do it all with 5s. So we're going to have to go sort of think about all the mutually exclusive cases that we could have. Okay, so we could try doing it with all $1. We could try using 1 $2 bill, and then you would have to use 3 $1. We could use 2 $2 bills. Maybe I should write out 2 here, $2 bills, and then you'd have 1 $1, or you could use all $5, right, which really just means 1 $5. Okay, so we got 4 different scenarios. You can either use no $2 bills, which means all 1s or all 5s, or you could use 1 $2 bill, or you could use 2 $2 bills. Okay. Okay, I just wanted to clean that up a little bit so it's easier to read. Okay, so let's look at the all $1 bills. Well, you have $1, $1, $1, $1, $1. You could put a bill or a coin, 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 a bill or a coin. That's going to be 2 to the 5th, or 32 different ways you could put all $1 bills or coins in. Okay. Now, let's look at this next one. If you're going to put 1 $2 bill in, and 3 coins, you're really going to put 4 things into the machine. Okay, and you have to first figure out, where does the $2 bill go? Right? Well, there's 4 different deposits. It could go in any one of those 4 places. So there are 4 different times at which you could put the $2 bill in. It could go in first, second, third, or fourth. And the other 3 are going to be $1 bills or coins. So you're going to have 2 choices for the first $1, 2 choices for the second $1, and 2 choices for the third $1. That's going to be 4 times 8, which is also 32. Okay. Now, if you're going to do 2 $2 bills, then you're going to have a $2 bill, a $2 bill, and a coin. Of course, the order matters. And in this case, we might want to figure out, when does the $1, sorry, not a coin, but a $1 bill or coin go? Where does the $1 go? Well, you have 3 choices. You could put the $1 in first, you could put the $1 in second, or you could put the $1 in third. Right? And then you would have 2 choices for the $1 coin. Right? But once you put the $2 bills in, there's only one way you could put those $2 bills in. Right? Because they're both bills. So that gives us 6 ways. And then if you're only going to use $5 bills, you only have 2 choices, either the $5 bill or the $5 coin. Okay? So all our cases together, if we add all these numbers up, we're going to get 64, 70, 72 ways. Okay? Now, if you really wanted to, you could try to write out all of those scenarios. Right? It could look like this: bill, 1B, 1B, that's a $1 bill, a $1 bill. It could be a $2 bill, and then a $1 coin. All right, that would give me $5. Or it could be a $2 bill, a $1 bill, and then another $2 bill. And if you sat and tried to write all of these out and think about all the possible scenarios, there would be 72 in total. Okay? Now, we don't want to sit here and do this forever, so what we'd like to do is be able to come up with a recurrence relation. And that's really the next part of this. We're going to try to write a recurrence relation for the number of ways to put n dollars into the machine, assuming that the order of the coins and bills entered matters, and we need to include the initial conditions. Okay, now once we get above 5, we should be able to come up with a formula. And the idea behind the formula, right, is that if you want to figure out how to put n dollars in, right, you could think about how many different ways you could put n minus $1 in, and how could you raise the current total by $1? Well, you could either put in a $1 bill or a $1 coin, so there'd be 2 times the number of ways you could put n minus $1 in to bring you up to n dollars. So if you already had $7 in the machine and you wanted to get up to $8, you could count up all the ways to get to $7 and then either add a bill or add a coin, which would double that amount. Okay, so if we think about n equal 8, then a sub 8, if you're only adding $1, would come from a7. Count up how many ways you could get $7 into the machine, and then double it, because each of those could be paired with a $1 bill or $1 coin. Okay. Now, you could have also started $2 down from the current amount, right? And there's only one way to make that jump, right? Because you only have one $2 piece of currency here. Okay? But another scenario is you could be $5 down and jump immediately to the value of n. Right? So if you were at $12, you could figure out what would put you at 7 and then add either a $5 bill or $5 coin. Right? So you have 5 bill or 5 coin. That would also give us 2 choices. Okay? So this is a recurrence relation that would take us to any value n. How could you get to n dollars? You could either start at n minus 1 and add a $1 bill or $1 coin. You could start at n minus 2 and add a $2 bill, or you could start at n minus 5 and add either a $5 bill or a $5 coin. Okay. The 2, the 1, and the 2 are the number of different ways you could make that leap from n minus 1 to n, or from n minus 5 to n, or from n minus 2 to n. Okay. Now the initial conditions is actually the harder part of this. We have to think about how many ways we could get $1 into the machine, how many ways we can get $2 into the machine, how many ways we could get $3 into the machine, how many ways we could get $4 into the machine, and how many ways we can get $5 into the machine. Now we've already answered 2 of these because we did a sub 3. We figured out that that was 12 different ways, and we also figured out a sub 5 was 72 different ways. Now a sub 1 is pretty easy. There's only 2 different ways you could put $1 into the machine. It's either a $1 bill or a $1 coin. Now for a sub 2, we have a couple choices. You could do all ones, right? Oops. That was supposed to be all $1 coins, right? Or we could do a $2 bill. Okay, so how many ways could you put 2 $1 bills in? There would be 2 times 2 ways to do that, and there's only one way to put the $2 bill in. So there's going to be a total of 5 ways, right, to put $2 into the machine. That's small enough that we could actually write them out. 1B, 1C, 1C, 1B. What am I talking about? Right, 1B, 1B, 1C, 1C, or just 2B. Those are the 5 different ways to get there. Now, a sub 4 is going to be almost as complicated as a sub 5. We've got to think of all the scenarios. You could do it all with $1 increments. You could do it with 1 $2 bill followed by 2 $1 coins or bills, or you could do it with 2 $2 bills. Okay, that's sort of the easiest one to do. If you're going to put 2 $2 bills in, there's only one way to do that. Okay. If you want to put all $1 bills in, right, you're going to have the same 2 choices for each. It's not $1 bill, sorry, it's $1 bill or coin. You're going to have 2 choices for each of those $1 increments. That'll give us 16. Right, so the only one left we have to figure out is a 2 followed by 2 1s. Right, now we actually did that in some sense. If you put a 2 and followed by 2 1s, you're going to have to put 3 coins or 3 deposits into the machine. So you have 3 ways to decide where that $2 bill is going to go, and then you have 2 choices and 2 choices for the actual individual $1 coins or bills. Okay, so that's going to be 12, 16, and 12 is 28, and 1 is 29. Right, so the recurrence relation is really everything. It's got to be how you get to a dollar amount of n from n minus 1, n minus 2, or n minus 5, and then you also have to include all the initial conditions. Now once n gets above 6, you should be able to use this recurrence relation, because none of these subscripts over here, 6 minus 5 would be 1, 6 minus 2 would be 4, and 6 minus 1 would be 5. You have all those values already completed. So if we needed to figure out a sub 6, we could figure out a sub 5, which is 72, and double it. We could figure out n minus 2, which is 4, take a sub 4 times 1, and then we could do a sub 6 minus 5, which is 1, and double that. Okay, it's a little bit complicated. It's a lot of work involved. Okay, but once you've done 1 or 2 of these, you should be able to get the hang of it.